Okay, so we have to find out if this sequence here converges or diverges. The way we do that is by taking the limit as n approaches infinity of said sequence. So we have the limit as n approaches infinity of this thing. The way we do this when we have a square root is to probably just leave the square root as it is. That's what I would do, is just leave the square root and then do as you normally would inside of the square root. So imagine there was no square root. What would you do? Well, you have a power to 2 in the numerator and a power to 2 in the denominator. So you would probably divide by that. You divide by n squared, both top and bottom. So the limit as n approaches infinity of the square root of 1 over n squared plus 4n squared over n squared, 1 over n squared plus n squared over n squared. So the n squareds cancel out, and you get 1, and here you get 4. You get 4, and you plug in infinity, what happens? This goes to 0, this goes to 0. So you're left with the square root of 4 over 1. You can still write the limit as n approaches infinity, even though there's nothing to plug it into anymore. I'm not even sure if you're supposed to write that at that point. Probably not. And it doesn't make a difference because the limit of a number is just a number. So we found our number. It's the square root of 4, which is 2. This converges, this sequence converges to the value of 2.